Hey, John, this is Doug. Is Rob on? I can't see all of the attendees.
I don't think he is, Doug. I just sent him the meeting invite to his new business email address. So maybe we want to go ahead and get started in his absence. I don't know if either you or Andrew want to kind of kick things off.
Yeah, I know that he was talking about doing a little bit of housekeeping stuff, but we can do that towards the end. But we can go ahead and get going. And it's actually my pleasure to introduce our speaker today. So, Mr. Kirk Steidel, hopefully you've had a chance to view his resume that was sent out with the announcement. But he's by far and away a leader in our industry on intelligent transportation systems, technology, design, deployment. And he comes to us as the Senior Vice President from Econolite and Econolite Systems, but he also spent a significant amount of his career with the state of Michigan as the director of the DOT. And so one of the things that I enjoy the most and appreciate the most about Mr. Steidel's approach to this is his perspective, as he brings a very unique perspective to our industry. And so we've asked him to share his thoughts on the state of the industry in terms of intelligent transportation systems, and give us his perspective on that technology and how it translates to our industry and what we can look forward to going forward. So very excited to have him on board. And Mr. Steidel, if you're ready, we can shift over to you and you can take it away.
Great. Doug, thanks for the intro, and it's great to be with all of you. As you said, it's hard to see the participants. I see a lot of dots and initials on the bottom, so I suspect there's a couple of you that I may know, and that's great. I wish we were, frankly, doing this in person. Won't that be great when we can actually go to a meeting and actually have in-person conversations? So I'm going to share my screen here, and I will right up front say that I use Zoom more than I do Teams. So let me make sure that you can see my presentation's just coming up here.
Yep, I can see it.
All right, and can you see, do you see just one slide?
Correct.
Okay, good, because I have a presenter's view and I want to make sure that you weren't seeing the presenter's view, so good deal. All right, so I want to talk to you about the things that we're doing today, but really with a view towards the future and understanding that the pieces, the ITS pieces we're putting in place today really are the foundation of our future. And everything that we do isn't done in an isolated cylinder. It's in context for where the world's going and where we as an industry are going. And I think it's really easy to think about, well, the future, it'll just flip a switch. Well, we all know that that's not going to happen. There's going to be a whole series of progressions. And frankly, I've found that the best way to think about the future, first of all, it's a very simple compendium, right? Wherever you're at now, there is, there was a past. It could be yesterday, it could be a year ago, could be 10 years ago, and then there is a future, and it's some point in the future. It could be next year, it could be next week, next month, next quarter, or it could be 10 years from now. So, when you say the future, okay, I've been involved in a number of national studies on the future of the interstate system, and my question usually back is, well, what's the future mean? When are we talking about 10 years from now or 50 years from now? And you all know that the certainty of 50 years from now is very much different. But I think in order to go forward, the most important thing you can do is go backwards. So let's stretch back a bit, and no, we're not going to go back to the driving of the Golden Spike and what did that change from a technology perspective, and how did that change the face of America. We're not going to go back. We're going to talk about all of those. But look at what's happened here over the time. So look at the agricultural age, the industrial age, the digital age of which we're in right now, moving into the information age, right? We've got all of this data. Now it's about how do we turn it into information. And you can see the last piece here is really the age of persuasive technology. It's and each one of those time frames gets smaller and smaller and smaller. And frankly, all of us on the call, we're going to be here. We're going to be involved in this industry in 2050. Now, some of us will be casual observers at that point. Many of you will be deeply engaged in leading companies and organizations all over the place. Now, as I said, I wanted to stretch backwards. Let's go back a little bit in time, back to the digital age, like these, revolutionary, game-changing innovations that we had from 1990, right? And I purposely picked this backdrop of these encyclopedias because about 2 weeks ago, I was having a conversation with some folks over Zoom, and I made some comment about encyclopedias, and then I realized everybody I was looking at had probably never had an encyclopedia in their hands. Now, I know some of you have. Doug has, for sure. But I thought of that and said, wow, encyclopedias, so that was before the internet. Before you could ask Google, you had to go open up the latest yearbook and find out what was the latest facts going on. Then that turned into Wikipedia, and Google just, found the way to mine that information. But as I look at the pictures, there's people on this call that have had every single one of those devices. A Walkman, you were really cool when you had a Walkman, right? And you got a tape, or Blackberries, or the thing in the middle, an answering machine, right? It was an actual machine that we actually walked in every night and said, okay, well, what are my messages? As opposed to, oh, I got a voicemail, an answering machine. So just think about that. That's 1980s, 1990s, really, starting, all of these are really kind of towards the late 90s. That's 30 years ago. 30 years ago. Frankly, it doesn't seem like that long ago, but certainly it is. So my point is to not pull any of those individual devices, but how we take this data, how we share information, it's really not important. Because, just look at this, right? Many of us can remember the Betamax versus VHS debates. Some of you are scratching your head going, what do those mean? But frankly, a Betamax machine was actually better than VHS, but VHS beat them out on the market because they had better marketing. But it didn't matter, because in a few years, they were replaced by DVDs, and then DVRs, and then Blu-rays. I remember Blu-rays came out. That was going to be the biggest thing. Everybody had to have a Blu-ray. And now we have Hulu, and now we have streaming. And it's guaranteed that in 5 more years, streaming will be old, right? And many of you are thinking, no, streaming's it. That's going to be, the cat's meow. No, it's not. There's something else will be developed. So my point here is you can't get locked into a single technology. It's a continuum that's going to continue to move through time. There will be something else. We are going to learn, and we're going to build. Frankly, that's what we as engineers do, right? If we think about the students that are in school right now, they're learning things that, frankly, when I was in school, hadn't even been invented yet. I mean, I still remember going to the computer lab with computer punch cards. And most people wouldn't know what to do with a computer punch card other than to, make a note on the back for, some old school thing. You'd have to use a pencil for that. But if we just think about technology and think about the Internet of Things, this scale, if you look at the very top, 50 billion things connected. Now, I tend to look at technology through my daughter and son-in-law, who are both about 30. They just bought a new house, and everything is connected. He can walk through the house and tell Google to turn on the Christmas lights. He can tell it to, turn on the pool lights. He can tell it to, play whatever TV station for their daughter to listen to. And that's going to continue. Just that piece alone, that interconnected house piece, is only a couple years old. And I'll guarantee that in 5 years, that's going to be old. There's going to be something new. So if you take a quick look at this slide, so we talk specifically about connected and automated vehicles. Here it is in one slide. 1939, GM at the World's Fair did Futurama. It said, this is what the future of cities are going to look like. It's got freeway systems through it. It's got self-driving cars. 1939. Well, it wasn't until 2004 we got to the DARPA challenge. The DARPA challenge, you know, look at that vehicle, right? That's the first autonomous vehicle that drove, I don't know, 7 miles through the desert. It wasn't even very challenging, but it's the first time a vehicle drove itself and made the decision, should I turn left, should I right, or go right? Fast forward to, you know, 5 more years, there's Google. There's the first Google driving self-driving car, and then you know you can progress that even further. And if you just spring forward into this year and think about some of the things that are happening now, it's really about automated, connected, electrified, and shared. And I put a question mark behind shared because, frankly, the pandemic piece has changed people's perceptions about whether they want to share a vehicle with somebody. Right now, I think all of us would be really hesitant that to get in a vehicle that just came from somebody else that we don't know. Were they coughing all over this thing? Right? The perception of that has changed. People are hesitant to get on public transit right now because of, you know, might I get sick with this? So I think the shared piece is coming back, but it's going to be a while. And frankly, I think there's a business opportunity for somebody to figure out how you disinfect a personal space after somebody leaves. And I think that's probably relatively easy, you know, coming from somebody that has no expertise in doing that at all. But if you look at the rest of this, automation is going to continue. It's in every vehicle today. And I think that the biggest hurdle here is going to be the cost of the technology being driven into vehicles, and at what point does a vehicle become just too expensive? Now, I drove through a car dealer lot last week, and the used cars were, if you could find them, they're about half as many as usual. The used car prices are through the roof. And I look at the technology that's in them and think, wow, this has way more technology in it than I've ever seen before. This was a used car. And if you think about the technologies in vehicles and understand and listen to what's happening with this microchip shortage, and think that there's hundreds of new vehicles sitting in a parking lot next to a manufacturing assembly line that are sitting idle, waiting for this little chip. That's all it needs. It just needs a chip. But I do think that's going to continue. There's a bubble going on here. They're going to get through it. You know, business is going to move into a space where there's an opportunity. There's an opportunity to certainly to manufacture chips and sell them. It won't be long. That supply chain will catch back up again. There clearly is a move towards connectivity. You know, Wi-Fi, 5G, all of that is going to continue, and it's going to get, I think it's going to even accelerate as 5G becomes much more stable and much more deployed. Electrified, you know, when I put this slide together a couple years ago, this was still a question mark. It is no longer a question mark. It is going to be electrified. You see automakers making very bold promises that by 2025, a certain number of vehicles are all going to be electrified. By 2035, all they're going to sell is electric vehicles. You see massive investments in manufacturing facilities for batteries. You see massive investments into research for better and cheaper batteries, longer life batteries. You see research going into the energy grid and how, if it is set up to handle 17 million new vehicles, new electric vehicles a year, and maintain all of its current functionality. So lots of challenges there, but electrification is going to be it's going to be in our future, and it's something that frankly we in the traffic industry need to be thinking about as well. If you look at the ecosystem of an automated vehicle, to me, this is really about partners, and they're partners that have never really worked together before. And I saw firsthand when government started working with automobile manufacturers, that many times they talked past each other because they had never, ever talked before. And if you look at all of the companies that are listed here, one common denominator is there's engineering to all of these. And in fact, the engineers that work at all these companies, while they might be electrical or mechanical or computer or civil or something else, they all started at the same engineering 101 as a freshman in college. Now, what I've seen is that we worked hand in hand for our freshman, sophomore year, maybe even junior year with our fellow engineers, and then we specialized, we went in our separate ways, and we all stayed in our own little bubbles of engineering, and we really never interfaced. I always like to say that the electrical and mechanical engineers in the auto system worked from the tire up, and the civil engineers worked from the tire down, and the only interface was the tread of the tire. Well, what automated vehicles are doing is changing that dynamic, and they're forcing all of us as engineers to work together, to understand that each of us have a particular interest and that it's in our interest collectively to use the strengths of each of us. Now, this came front and center to me probably about 4 or 5 years ago when I was still at the Michigan Department of Transportation, and I was having a conversation with an engineer from an auto company, I won't say which one, that was explaining to me how he had he was trying to figure out the signal timing to be able to put into his vehicle for this automated system. And he said, I've been working on this for about 6 months. And I looked at him, and he's a friend of mine. I wanted to smack him. I said, that's what traffic engineers do. We could have done this in about 4 hours for you. You spent 6 days or six months trying to figure this out. And it was just that attitude that nobody had ever solved this problem before, and he was going to solve it, when in fact, look, there's a whole nother discipline of engineering that understands traffic engineering. And that was a big eye opener to him, because he looked at me, he said, you mean you guys have already done this? I said, yeah, we've done a lot of that. In fact, the traffic signal does a lot of this. So he was just amazed. It was the first time he really started thinking about the other disciplines of engineering. Now, I didn't mean to go off on that side note for a minute, but I know for all of you on the phone, you've experienced that. And I think that we really need to, as engineering professionals, and particularly ITS professionals, really need to lean into those conversations and think outside of our normal group of engineers and seek opportunities to be part of the solution instead of just complaining about it. All right, so back to this. So automobiles, lots and lots and lots of data, terabyte of data. There's sensors all over those vehicles, and that gets to my point of data. It's the digital age where we've got lots of data. Now it's time to put that into information and actionable information. It's one thing to know, yep, the wipers are on and the defrosters are on. Okay, good. You know the status of two systems. But can that inform you that, hey, maybe it's 35 degrees and maybe the road might be slippery and maybe the traction control should be ready as well. And maybe that information should get telegraphed to the agency that's in charge of doing road maintenance, whether it goes through a traffic signal or goes through a cloud-based or whatever. It's about turning that data into actionable information. Now, some of you have seen the Geithner hype cycle for emerging technologies. If you haven't ever seen this, just Google it. And every year they come out with a new one. And this is probably a little difficult to read, but I tried to put two of them here because one is from 2017 and one is 3 years later in 2020. And you can see that as it goes up this axis, there's lots and lots of technologies, and this gets way up here to the peak of enlightenment. Let me make it a little bigger so I can see it. The peak of inflated expectations. Sorry about that. And then there's the trough of disillusionment coming down the other side. It says, oh, well, it really didn't do all these things. It then moves off into the slope of enlightenment and the plateau of productivity. So every single technology that we've talked about, the ones from 1980, 1990 were on this curve. The ones that we're dealing with today are on this curve. And to me, it's really interesting to just watch this from year to year and see, okay, what's happening. So, I listed some of the ones on the side here. The blockchain, end-to-end security. I will tell you that with what just happened with this pipeline, the end-to-end security is going to be front and center. And as I've said for a long time, in our industry, we need to be very mindful of the end-to-end security as well. I mean, we all joke about changeable message signs on the side of the road, the orange ones that say, beware of zombie apocalypse. But I think every person would be very, very concerned when one of the big DMS signs actually had that kind of information and was hacked, which leads to the larger potential for an entire agency's signal network. And if there's a way to get into their larger financial networks through that system as well. So I think security is certainly going to be a very big issue going forward in here in the next 6 months for sure. So if we look at some of the issues all over society, you've got urban issues, you've got rural issues, and many of those are similar. But in the urban areas, you've got the first mile, last mile, you have curb space management. As automated vehicles are pulling up, where do they pull up? Do they just double park? You have the influx of cyclists and scooters, and I firmly believe that's all going to come back. The shared aspects are just going to be a little bit different, but that's all going to come back. The last two, access and equality, as I talk with DOT secretaries and directors across the country, that is the biggest topic. How do we provide access to the society? And if you look, that's on rural and urban, access to healthcare. How do we do this in an equitable fashion? And while we as engineers like to think of everything as a technical problem to solve, this is a societal problem that's going to cause us to think a bit differently and make sure that what we're doing is scalable, not just to the people that can afford it, but to the people that need the access as well. And then, the rural side, it really is about access to broadband, but more importantly, it's about access to services. How do we help people get and stay connected? And frankly, those are issues that we as engineers can all help solve. And I think it will be solved from an engineering perspective. Now, let's jump a little further forward. And I trust that everybody knows that this vehicle, the DeLorean, was an actual vehicle. It wasn't just created for Back to the Future. But let's jump into it to go a little further into the future. So we have slow speed shuttles. These are pictures of shuttles that are already deployed around the country. You're going to see more of those. In some cases, they're really viewed as a toy. They're viewed as, this is interesting. But this is the beginning of a larger vehicle that moves around a particular geofenced area completely autonomously. It's essentially on a track. It knows where it's going. It can sense what's going on around it and make judgments and adjustments to it. But we'll see more slow speed shuttles, and I think the speeds will increase. Right now they're, as I said, a bit of a novelty, but once they begin to speed up, provide more reliable service, this will be a real opportunity to help with those last mile issues in urban areas. Now let's take this low speed shuttle and let's think about that rural complex of access to services. There's nobody that's going to get in a vehicle like this and ride for 3 hours to go to a doctor's appointment that's 10 miles away, right? The vehicle is going to be too slow, but the technology is going to continue to evolve to where it's going to help solve those problems. And maybe they're going to be medium speed shuttles in the future. Some would say we already have high speed shuttles. That's, there was just a recent crash with somebody sitting in the backseat of their Tesla. But I think many people have also realized, boy, there's a lot of limitations to that as well. And I know that there's a lot of traffic engineers in this audience that are cringing over that right now. Amazon, working on last mile shipping. What I just saw was a grocery store chain close to where I work at that has been doing the, you can drive up and get your packages. They're going to start experimenting if you're close to the store of can they send that to you via drone. Now the other cool thing that I saw was a pizza chain that was talking about doing that, to where you could dial up your pizza chain as you're at the park and you're with a group of friends, and you can dial up the pizza chain and the drone will bring you the pizza in the park. Now, there's a whole bunch of societal issues that are going to go along with that, about noise, FAA regulations, and a whole bunch. But technology is moving there. And frankly, I think once it's technologically possible, it is impossible to stop it. So it is going to happen. So we're going to see in the next 5 or 10 years the delivery of significant packages, frankly, maybe even people, via drone. Now, this company, Refraction AI, is actually delivering goods. This is in downtown Ann Arbor, delivering goods within a 2-mile radius of their facility in this little pod. And it drives the streets of Ann Arbor, and you get there and you open it up and you pull your stuff out, and then it closes. Now, what I did here is that they've worked on a way to disinfect that. Now it can have multiple components, so you could certainly see that it would make one trip out and make 2 or 3 stops along the way. We're going to see more and more of that as it goes forward as well. This vehicle is driving around an airport. In fact, this happens to be Detroit Metro Airport. This was created by a company northwest of Metro Airport in Detroit that drives around and disinfects large areas. And it works all night. There's nobody else there. It's just spraying down surfaces and disinfecting large areas. Human augmentation is going to continue. Each one of these has some form of robotics assistance. The one that I found the most fascinating is that bottom right corner, where if you watch a video, you can actually see it. It's putting the bricks on the facade of a building, all via a robot. It was absolutely amazing. And the picture I like in the middle is this person wearing an exoskeleton that is carrying a 200-pound beam. Now, in the manufacturing world, that's not unusual. You will see assembly lines that are where there's an additional assistance, an exoskeleton on a person that's helping to move very heavy objects into that assembly line to assemble a vehicle. So you think about how does that transition into the transportation, into the traffic world as well. Wearable tech. This the furthest one on the right there is actually a phone that can curl up and go around your wrist. Now, I was at the Foxconn facility in Japan. Foxconn makes all the digital displays, and I was there 2017, sorry, and saw TVs that were like a piece of paper. They were so thin that they actually you could see them move in the wind, and you could see projections, two different projections on each side. So and it wasn't 4K, it was 8K. So it's absolutely coming, which means that becomes part of the wearable tech. That becomes part of that shirt that you wear. Not that you're going to be projecting everything, but it can now have sensors all over it. This is what's your body doing, what's your temperature, what's your heart rate, can really help in optimal performance. And then, you know, this crazy picture from CES of an individual helicopter. This reminds me of some of those pictures from you know, the early days of the Wright brothers and everybody thinking about how you can fly. But, you know, I think all of those will pan out in some fashion. And then, of course, there's the vehicle to everything, right? And we hear this a lot. It's about V to V and V to I and vehicle to pedestrian, vehicle to the network. It's really the vehicle to everything. That goes back to that initial slide that I had up front that had all of these data sensors all over the vehicle. And how can we use all that data to give better informations to citizens? Remember, we as traffic professionals are in this to improve society. I mean, the technology is neat and cool, right? And we can get all wrapped around the axle about the technology, but we have to step back a bit and think about, now, why are we doing this, right? We're doing this to help provide greater mobility for our fellow citizens, right? There's you know, a lot of us can get really excited about the technology, but we have to understand why we're doing it. And when we can put the why behind it, that's when the rest of society starts to see the excitement that we see because of the technology. So change can happen really fast. As I showed, we just go back 30 years. I want you to look at this picture. And this is the course of 13 years. Some of you have seen this example before. This is New York City, and it's the Easter Day Parade, both times, 1900 and 1913. Easter Day Parade, same street, obviously not the same view, same street. The 1900s picture, see if you can find the one car. There's one car in that picture. And I don't know if I'm going to be able to use my pointer here and point it out. But if you look at 1913, there's one horse in that picture. So I don't know if you can see my cursor or not, but it's over on essentially the parking lane so all that traffic is coming towards you in the screen. So it's on the far left side. Look over, you know, along the curb line, there is one horse. Or I'm sorry, there's one car in there. And if you go to 1913, same spot over on the edge, it's a little closer. There's one horse over along the curb line in the back. So the point of this picture is that's 13 years. Look at the dramatic change that happened in 13 years. In 1900, they didn't need a traffic engineer. 1913, they were starting to realize we got to put some order to all of this mass chaos that these vehicles are developing. And frankly, that's when the traffic engineer became more and more important. Now, here's the last slide. Here's the famous picture of the Empire State Building and the workers up on top. Who knows what the next big building is? And there's a robot. There's human augmentation that's building that building. Who knows what it's going to look like? We do know that technology is going to advance. We know it's going to be different. It's upon us as humans to figure out how do we leverage that and how do we use it to the best of society. And frankly, in the traffic area, it's about how do we use this technology to provide better mobility for the future. So back to my initial slide that says what we're doing today is the building blocks for tomorrow. If we as engineers are pushing the edges of technology, saying this is what's possible, maybe not the bleeding edge, but the leading edge, helping our customers, helping society harness this technology, we're putting in place the opportunity to leverage more technology in the future. If we as society say, you know, the best thing to do is to stick with that BlackBerry from 1990 because that was really good technology. No, we shouldn't be doing that. We should be building, setting the foundations that allow for that flexibility of technology to move forward, to enable society to get better and better and better. So with that, I would be very happy to answer any questions, get into a discussion with you all at the same time. So Doug, thank you for the opportunity.
Oh, thanks, Kirk. I love listening to this perspective. And I actually have several questions. I did put a note into the chat that if somebody wants to ask a question, they can put it in there and I'll read that. But you brought up a lot of tantalizing concepts with this. And so I'm going to throw a couple of them out there and you can respond, and other people may have some questions. But first of all, when you showed the drone from Amazon and the delivery, you're talking about the pizzas, you're really adding a third dimension to traffic engineering and traffic operations. So I'd love to hear your perspective on that. And then I'd also like to make the observation that I appreciate you calling me out on the encyclopedia thing and then bringing it back by reference to the BlackBerry, because I still hold on to that as a great product. But scary enough, the pictures you showed from 1900 and 1913, our road design hasn't changed that much. And so how, as a traffic industry, do we begin to make what would be immense infrastructure changes that probably have to start with a change in overall approach? So there's a couple of things. And then my last thing, and some others can jump in as well, as when you showed the building block slide, there was a company, Continental, that was on like four of the 8 building blocks. Is this vertical integration? Is that something that we're going to have to be concerned about sometime down the road, or some of these companies? Is it a consolidation? There was a lot of things. You're going to try to get a lot of engineers to cooperate just to get those building blocks together. How do you see that shaking out long term? So there's a few things for you to start with.
All right, let's see if I can put my old memory to use here. And so let's start with Amazon. You're exactly right. So, and this is frankly where the aeronautics engineers and the electronics engineers are going to need to work with traffic engineers about how do we solve this third dimension. Because you can, that picture from 1913, I referenced chaos, right? There's chaos going on with these vehicles driving all over. I can't remember what year, it was 1920 that the first paint line was put down on the road, which helped separate the chaos, right? That's what I envisioned it between 1913 and 1920. There was traffic engineer types that didn't know they were traffic engineers that were going crazy because people were all over the road and they weren't coordinated, right? So that's exactly what's going on now, that many of us are thinking, wait, this is crazy. We got these drones are going to be flying all over the place. How do we help control that? I do think there will be some form of coordination, and I'm very hesitant to use the word regulation because I don't think that's the case. There's going to be some form of mutual coordination that's got to develop, and there's got to be a private business side for developing it. But I do think within the next couple of years, we are going to see a lot more drone deliveries. And the whole notion right now is that you can't have a drone go out of sight. You can't fly drones over people. I think that's going to continue to fall away as well. Now that leads to your second question there about the road design. And frankly, you're exactly right. Now, one of the pieces I mentioned as one of those challenges in the urban area was curb space management. And if I think about a design of a road, as long as we have vehicles that are on the road and we've got, we're producing 15 million new vehicles in the United States a year, there's always going to be a lane that is somewhere between 8 and 12 feet wide. So that's always going to be there. But what's going to change is what happens on that outside edge. What happens where the curb's at? Where's the space for the cycles? Where's the space for the scooters? Where's the space? What's the separation for the outdoor cafe? That's a piece I think that we as traffic engineers need to think about. How do we help design this so it's a community as opposed to it's just a roadway that pushes people through? So I think it's really understanding this notion of a complete street is much more broad than that. So, and I see there's 3 other questions popping in here, and I'm going to trust you or Stephen or something to digest those. They're popping faster than I can read them. So, let's see.
Yeah, so I know Stephen had one of the first ones he brought in was in asking for a recommendations for people who will still be working in 30 years as our profession itself adapts to future changes. And Stephen's on, so if he wants to expand on that, but in terms of our traffic engineering and our disciplines and the different aspects that are adapting to the technology.
Yeah, I think it is exactly that, right? So the industries that fail to adapt will fail to exist. So think about in that 1900s picture, one thing that every one of those vehicles had on it was a buggy whip. And in 1913, there was no buggy whips. So if you manufactured buggy whips in 1913, your business model was gone. Now, if we just think about our business of traffic engineering, this really leads into the anthem that we've heard so many times. It's called lifelong learning. We have to continue to learn and evolve and develop our skills. We need to take those skills that we've developed, whether you've been in this industry for 5 years, 10 years, 15, or 35, and you have to take those and continue to adapt them. If you're still doing what you did in 1985, it's going to work for a little longer. The basic skills are the same. I'll guarantee if you used to do signal timing in 1980, the fundamentals are still the same, but the tools you use are different. So the tools have to be continually updated. So Stephen, you're still going to be here in 30 years. I'm trusting you're going to continue to evolve those skills and learn those new technologies. Just think about synchro, right? Synchro wasn't around 15 years ago. And, frankly, people have learned how to use it and learned how to excel. Even when I think about some of the specific technologies that are coming along in some of the technologies that Econolite has, I've had traffic engineers say, well, but that's my job, right? Because it's giving a recommended timing change. And the engineer said, well, that's my job. I said, no. The traffic engineer becomes more important because before they would spend all day crunching all the data. Now the computer crunches the data and the traffic engineer says, okay, there's the data. Here's what we got to do. They turn it into actionable information. That's the piece where we all have to continue to evolve, and that's how we all stay relevant and we stay engaged in the conversation.
So Kirk, I'm actually going to combine a couple of questions because I think they're applicable to be put together, even though they're separately asked. So Mark Parrington is asking about automated vehicles and the roadway features and whether the vehicles themselves will be able to overcome that, or if we're going to have to go back to a more standardized design. And then Joe followed up with a question about your perspective on the regulatory scheme, and I think those two are somewhat related.
Yeah.
Because if does it become a Wild West and then reins in, or does it get reined in and we never become the Wild West? So I'd love to get your thoughts on those.
You know, and those are two wonderful questions, because that's exactly I think the quandary we're in, right? And it's the same thing with how do you roll out automated vehicles? Do you just let it happen, or do you put down a prescription that says it must happen this way? And you can look around the world and see different approaches. You know, you can go to China where they said it's going to be this way, boom, 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 boom. This is how it's going to operate. We're going to develop the technology. We're going to pick it all. Okay, that's one form. And then you look at America's perspective, a U.S. perspective, and it is more about private entrepreneurs and the development and helping to advance technology. Now, I can say that there's a lot I can see, and there is a lot of waste in that approach, because you have individual companies doing research and development on the same things, but at the same time, you end up with a product that probably is better because it had innovation going all the way through it, as opposed to it was dictated, here's what will happen. So I think it's a bit of a balance, because if you do, you know, if it is all just government centric, you end up with a bit more groupthink and less about innovation. When you get to this notion of the drones flying and, you know, they're going to be bumping into each other, I think what's going to happen, and I don't disagree with Joe's statement here. It's a balance between the two, because FAA can't keep up right now with where drones are flying. NHTSA can't keep up with the technology that's coming along in cars, right? It takes them 2 years to develop a rule as to how they're gonna, you know, what's gonna happen, how they're gonna be able to interact. When in fact, 2 years from now, the technology has already changed. That's why I say this is gonna take some coordination between the private companies that are actually deploying these, because they're going to deploy them faster, and frankly, they're going to have an influence into what the FAA said this is allowable, not allowable. So I think it is truly a balance between the two. I didn't mean to leave it open that says no, just, you know, private industry is going to solve all of this, and you know, I'm the ultimate capitalist. That's not what I'm trying to say at all. But it's not government will dictate what will happen. That won't fly either. It is going to be a collaborative process between the two.
Yeah, and I got one more follow-up question, and somebody else can chime in if they want. So you're speaking to the Iowa section of ITE, and we're a newly formed group. We used to be a chapter. You know, we're part of the Movite district, which is a wonderful ITE district in the Midwest. So you're talking to the group of folks who are most vested, I think, in the industry and most interested. And I know, looking through the names, I know most of the names, and I know these are people that are really appreciating some of this technology and the perspectives. So my question is, what can a group of professionals do, or how do we stay both abreast of this, and how do we influence it in a positive way, or stay out of the way so we're not negatively influencing this as an organization?
So I think there's a couple things. One, we need to be continuous. We need to be curious, right? We need to be continuing to learn, and that's multifaceted. That's not just I want to learn my particular area, but I want to look broadly about what's happening in other areas, and are there transferable things that can come into what we're doing, right? So we have to make sure that we stay relevant in the conversation. The second thing is, we all need to be evangelists for this, right? When we know there's good technology that's going on, and you know, many times we need to take our own corporate hats off and just talk about technology and society, and we become the best evangelists going forward. Now, every one of you has been the bore at a party where somebody has asked you some technical question about why I get stopped at such and such signal, or why you all have done it. I've had it too, right? And you immediately take a deep breath, and then you dive right into the technology, and in about 15 seconds, the person's going, I think my mom's calling. I got to go do something else. And frankly, I have been, victim of that myself. I have done it. And I think we'll have to be very self-aware. We have to end up with what I call an elevator speech that talks about where is this whole technology space going in 30 seconds, right? And to some engineers, that's impossible. It's like asking them what time it is and they tell you how to build a watch, right? We are all guilty of that. We have to understand that they asked for what time it was. Tell them what time it was. Don't tell them how the watch was built. We need to take a step back and say, look, here's the implications. Here's what happens with technology. We don't need to get into, well, this detector does this and this one's better than that. Forget all of that. It's about where's the technology going in a very high level and get people engaged. And if there's some way to continue to bring it back to your own individual phone, your own personal experience, that's the best way. And then that saves you from being the bore at the party too. And then you'll get invited to more parties.
Well, I try to never be the bore at the party, but thanks. Does anybody else have any questions? I know I've kind of hogged to that. I appreciate the ones that put it into the chat. That was very helpful.
I see somebody with a hand up, but I can't see.
Yeah, Kirk, I had a quick question on how do we as representatives of the public and folks that, we want to make sure we are providing care to taxpayer dollars, but technology is moving so quickly. How do we handle when we have worked through the process of installing new technology that's almost immediately becoming obsolete? Example
Yep.
being, and obsolete's not the right word I'm going to use for this example because it is not obsolete yet, but DSRC, right? If the federal government is removing that bandwidth for the safety and traffic spectrum, do we need to go to, how do you know when you pull the trigger on certain technologies? And with most of our industry, things sometimes move slower. So as soon as you have this new thing in, all of a sudden it's obsolete.
Meredith, that is a great question. And, I'll put on my former DOT secretary hat. And that is a very tough question to answer because it looked like it's DSRC all along, and then all of a sudden it's not. And what I saw going on was there was a lot of hype. If you remember, it was 5 years ago. It was going to be DSRC is the answer. It's going to be here. And then the new administration comes in, kind of changes the dynamics. And the discussion at the time was 5G is almost here. That was 5 years ago. Why isn't it here yet? It's because there was a bunch of hype going on at that time, right? So you make a very, very solid argument for a public agency and when you should, when you shouldn't. And frankly, it really a lot of times will depend on whether the agency wants to be on the bleeding edge or the cutting edge. Now, I was fortunate in Michigan. I had a governor who was a tech nerd. He referred to himself as a nerd. And he encouraged us to push the envelope. So I had the backing that I need. That doesn't exist everywhere else. So it will change. But I think the best way to go about this is more of a performance based, because technology is going to change. It is going to change fast. Even the stuff that we have out there today is going to change in 2 more years. You're going to say, well, that's obsolete. And I agree with you. Obsolete's the wrong word. It still works. It's still fine, right? If you have a 4 or 5 year old smartphone, it still works. But the technology will have advanced. I think one of the best things to look at is the procurement process and change from a very specific specification driven contracting to a performance contract that says, I want your system, whatever it is, to do X, Y, and Z. I want it to give me these kind of results. And you tell me what system you have that can do that, and then show me how you're going to keep it updated with technology as it moves forward. Now, as a public agency, you have to be mindful that every time you put in guaranteed upgrades, it's going to cost you money. So you have to balance that with how far out do you want to build in automated upgrades into a contract up front. But I think and I see more public contracting going to a performance base as opposed to a very rigid specification based. And that's not just in the traffic world. I see it in all types of procurements, whether it's asphalt for roads or concrete, or performance of bridges. I really I think we need to move as an industry, not just traffic, but as civil engineers, into more of performance outcome based as opposed to specification based.
Thank you very much, Kirk. I know we kind of wrapped up most of the time that we'd allocated for that, so I especially want to thank you and Allison Bone from Econoline who helped organize this for us. Again, I love the perspective that you bring, both from the technology side as well as the experience through your DOT years. And so I don't see any additional questions right now, so I'll leave it with a great thanks. But if anybody does have follow-up questions, you can forward those to me or to somebody on iSight, and we can make sure that they get to Kirk and Allison and we get those answered for you. So I appreciate it very much.
Hey, Doug, I would offer one other thing to Meredith's point. If there's a public agency that has questions about that, having spent most of my career in a public agency, I would be very happy to sit down with them and help them think through what some of those solutions look like as well. I mean, just have them send the contacts or the questions through you, and I'd be very happy to reach out and have a separate conversation with them about unique problems associated on the public sector side, seeing I spent 30 plus years there. So
thank you very much. Rob, I think, are you on? We can hand it over to you for the rest of the meeting. So, thanks, Kirk. Thanks, Allison.
Thanks, Doug, and thanks, Kirk, for the presentation. It was very informative and great information. I just have a few things as far as iSight, what's going on with our chapter or our section, as well as some of the other things that are going on. So within our section, we're looking at having our next month's meeting cover safety trends during 2020 and how COVID, and then also how the derecho affected traffic and safety. Then we also have a couple of opportunities within iSight to help out as director positions. So there's a communications director, which John has sent out the information for that. And then we're also looking at a young member liaison to help with our connection to Iowa State and University of Iowa, and then also the younger members and helping them be active. So we'll be looking for both of those. As far as ITE goes, make sure and look at their calendar on their website. They have a lot of meetings and virtual drop-ins and different activities going on. And one that I want to point out is the annual meeting is going to stay virtual this year, and that will be July 20th. And it's 2 weeks for the virtual meeting and then a third week for technical conference sessions. So it runs through August 5th. Registration is open right now. And with it being virtual, it's a lot cheaper than if it were in person. So I know I attended last year and a lot of good information, some of it similar to what Kirk talked about today, and then some other, or there will be a lot of other information. So make sure and check that out. I know we had scheduled till 1:30, but we don't have more today on for our meeting, so we can let you get going early. If there's any questions or comments, you can direct them to us at the board, and that is, we have an email, or you can get a hold of any one of us. The board email is board@iowaite.org. And there, Stephen just put it into the chat for you too. So thank you everybody who came today, and thank you, Kirk, for your presentation.